Going on to topic 2 of chapter 5, we're dealing with systems of linear inequalities now in 2 variables. And we're asked to solve them graphically to find the solution region, which is sometimes referred to as the feasible region. So these are our first 2 equations or inequalities. And we're asked to graph them. Well, this is in standard form, and this is in standard form. And I've said that as a tool, when something is in standard form, a good tool is this X and Y-Intercept T Chart. So let's use it for this one. If X is a 0, Y is going to be 6. If Y is a 0, X is 6. So we have our X and Y intercepts. You recall 0 comma B is our Y-intercept, where the line will cross the Y-axis. A comma 0 is where the line will cross the X-axis. So these are good points for graphing. Now as I look at the second equation, or inequality, notice we don't have a value there. So the T-chart's not that valuable. So what I've done is I've solved for the letter Y by bringing the Y over to the other side. And now I have Y, if I read it this way, Y is less than or equal to 2X. Well, most students like to read it from left to right, so I just took this. Again, the point is toward the Y, and rewrote it in a more familiar way. Now this is in slope-intercept form. Now remember, because there is no B value, B is 0. So this indicates that this line is going to go through the origin as its X and Y intercept. So now let's graph it. But notice what we've done so far is we've solved these as if they were equations. And we're just going to get lines, and because it also is equal, they're solid lines. But we have to do some shading. But let's get the solid lines in there first. And we'll color code it. We'll make this one a blue line. So, 0, 6. 1, 2, 3, 4, 5, 6. A dot right there. There's our Y-intercept. Now our X-intercept is also 6. 1, 2, 3, 4, 5, 6. Now, today I brought a ruler so I could get some straight lines. So let's just draw that in. A little bit better than what I do. Now, the other one, to make some difference, we'll put it in red. And this is, our slope here is 2 over 1. Our Y-intercept is 0. So we put a dot at 0. Now, it's positive slope, so I'm going to go over my run, which is 1 unit of X. My rise, which is 2 units of Y, and I now get this one. And I've put those on as if they were equal signs. But now I'm asked to shade. So where do I shade? Well, there's a couple of techniques, and let me show you at least one of them. For the red line, what does this say? A positive y is less than this. So that means we're going to shade under the line. So we're shading in this direction. Now, in this case, it's saying, again, we can forget about that for now. We have a positive y is greater. So we're going to shade above the blue line. Now, what we're wondering is, where do these shaded areas intersect or overlap? Well, they overlap right here, between underneath this and above that. So this, and I wanted to use green, and in your math lab, you have a bucket of paint that you slosh on. Now there's another key word that we want to note here, that these lines are intersecting at this point. So this is called a corner point. And we don't know the value of that. And another corner point, depending, but we'll just use that one for right now. Okay. Now, let me just add to this that in this green area, that is your solution region. It's where both of these are true. Items along this part of the red line, this part of the blue line, and then all points in the green line make both of these statements true. That's the ordered pairs that are out here. And again, I'm sketching the graph, so these points aren't exactly equal, and neither are these. But according to our textbook, this point of intersection is at 2, 4, right about there. I'm a little bit off. Now you might say, how could you find the exact point? Well, you would then treat these as if they were equations, and you would set them up as we did in a previous lesson in standard form. X plus y equals 6. 2x minus y equals 0. Notice the y's cancel out, and you're left with 3, when you add them together by elimination, 3x equals 6, x equals 2. And that's what we got there. And then if you put the 2 in, let's say this, you would get the 4, because this would be 2 times 2 is 4 minus y equals 0. Just transpose the y equals 4. Okay, because later when you get fractions in here, this is going to be the method you use to solve it. There's a lot to do on this. So I'm going to break just this one example up into parts so you can see how I would think your strategy for doing it too. Here's our first equation, or inequality, second, third. And then they're giving us these qualifiers where they're saying x is greater or equal to 0, y is greater or equal to 0. So that means you're going to be in the first quadrant. That's where you're going to be working. So anytime you see this, you're not worried about the second, third, or fourth quadrants. You're going to be in the first quadrant. And these lines are actually your axes. Okay. So again, all of our inequalities are in standard form. So I would think the best approach to solve them, and we're doing this graphically, is to put them in that special Y-Intercept T chart. So the red one deals with this line right here, the blue one here, and the green one there. Now again, if x is 0, y is 22. If y is 0, we're going to divide both sides by 2, x is 11. Here, if x is 0, y is 13. If y is 0, x is 13. That's pretty straightforward. And here, if x is 0, y, we're going to divide both sides by 5, is 10. And if this is 0, x is 25. So those are my x and y intercepts. And what I've done here is I've made these points 5. And we do have graph paper available at the front desk if you want to work on that. But graph paper gives you a more accurate depiction of what's going on. And you might say, how did I pick these parameters for the sides? Well, I looked here and I see my largest number is 25. And here it's 22. So 25 by 25 is pretty good. So let's do the first one. I'm going to color code these. So for the red, we have 0, 22. So right about there. And then 11, right about there. And in fact, I'm going to set this up to save a little time and then get back to it. Now, as we plotted these, you recall that this was the red line, the blue line, and the green line were the three inequalities that we had. And a positive y in all of these cases was less than something. So we're shading the under portion of each of these lines where they intersect. So that gave us this purple region here. This was our solution region, the feasible region. Okay? Now, for our corner points that they're going to ask you, we have a corner point of our solution region is here, there, there, and there. Now, if they're on the axes, you know the points that you plotted. It would be this one and this one you might be somewhat unsure of. But if you've done your graph carefully, and these are on the actual grid lines, so you could pick them up. So going from this point down are corner points, and keep in mind we also have this as a corner point, 0, 0 over here. This one is going to be 0, 10. That's our Y-intercept. This one out here is going to be at 5 and 8, right over there. Again, my graph is pretty good, and I'm using a ruler, so that helps. Now this one is going to be 9 and about 4, right there. And this is your X-intercept, 11, 0. So I'll broaden it out again so you can see the whole thing. That's the magic of our little camera here. So our strategy for doing example 2, we've written the inequalities out. We have our qualifiers. We know it's in the first quadrant. We want to find the X and Y intercepts of these. We made our little T charts. Then we carefully plotted this into our graph, and graph paper is very useful here. And then we saw where they intersected. It was all that Y, positive Y was less, positive Y is less, positive Y is less, so they were under. So this filled in the region, and we now have our corner points defined. In example 3 that we're working on right now, this is an application where it's dealing with amounts of medication that a patient is required to have. And they give all the details in the textbook that if I tried to put this in the video it would be way too tedious. And eventually, this is what we come up with, and there is a chart, and if you're going to do one like this, again, you want to have a model to follow, and this is what you end up with. So then what we're doing here is we're looking for a strategy of how to graph this, because that's what they want us to do. Well, again, it's inequalities in standard form. So I'm strongly suggesting that you use a T chart, because this will give you your Y and X intercepts. And it'll also give you a clue as to what numbers that you want to put on this graph. So when we solve this using the X and Y intercept T chart, if X is 0, Y is going to be 42. And if Y is 0, X is 8.4. And I'm coding that in red. Our second inequality is in blue. So if X is 0, we divide both sides by 4, and we get Y is 30. And if Y is 0, we divide both sides by 8 and we get 15. So now, based on our little graph, and again, these are the qualifiers, putting it in the first quadrant, what numbers do we need on our graph? Well, here we're going to need a 42, and here we're going to need a 30. So 42, 45, let's say along the y-axis. And then for the x-axis, we need an 8 and a 15. So to kind of keep it in balance, we'll have this one 45 and we'll have this one 45. And that's what I'll set up. I'll leave the big shot out there. So again, as we figured out from what the book is telling us, these were our basic inequalities. Since they were in standard form, we put them in T charts to get our X and Y intercepts, color-coded them so you could see. So for the red, it was 0.42, 8.4, and then it was 30 and 15. And when I drew the graphs carefully with the ruler, I saw they intersected right here. So this is a corner point. The other corner point is this one, 0, 42, and 15, 0. So corner points. Now you might say, well, are these corner points? No, because they don't meet the requirements of what we want. And since both of these, y is greater, we shaded above the line. Now, what does this tell you? If you look into the details of the problem, they're saying in order to meet the daily requirements of this drug, you would need 4 units of drug M and 22 units of drug N. Now, the book is suggesting that if you had, let's say, something over here where it would be for, let's say, 21, which would be on this side of our solution region or feasible region, that would not meet the daily requirements. So anything out in this area, and again, some of this out here would be in excess, but this on the line and out in this area would meet the daily requirements. Okay, so again, you're going to do some practice. In fact, I only did 3 examples, so let me do one more example taken from the textbook at large. All right, this is just an example, example 20 out of our textbook. And there are 3 equations. Now, the key to this is that each of these inequality symbols are less than, and all our y values are positive. So that once we draw the lines, they're going to be solid lines, we're shading under the lines. And this just puts it in the first quadrant. So we take our red equation or inequality, put it into our T chart, get these values for the blue inequality, these for the green. Now, looking at these values, I see my largest y is a 21, my largest x is a 21, so these give me the parameters of what to set up. I'm going to use it in intervals of 9, and 5 I should say, and there's my 21 there, there's my 7, 9 and 9, 0, 7 here, and my 21 there. So again, I'm looking for the intersection of these, so it'd be below the blue line, below the red, below the green, and that's my solution region or feasible region. One of the words they ask here is, are the regions bounded or unbounded? Well, in this case, since it's within this area, it's bounded. If it were out here, it would be unbounded. So we didn't mention that word before, so a good thing. And then what are the corner points? Well, again, this is our green one, is our Y-intercept, 0, 7. Now, if you had graph paper, it would sort of be easier to pick out these other corner points here. But it's 3, 6, 6, 3, and then our red one here is 7, 0. Now, whether this looks exactly like a 6, 3, again, because my graph is not that accurate. This is a sketch. And in fact, how did I find these? I did that by taking the intersection of the green and blue lines. If I did those as we did in earlier sections, I would find the intersection of that point. So that's always a backup if you don't have graph paper. But graph paper makes it easy. Well, good luck on your practice and quiz me's on section 5.2.